Like relevance, let's prove that the left hand side is equals to the right hand side. So let's focus on the numerator on the left hand side. We have two terms, sin of x and sin of x cos of x, and we can see in the numerator sin of x is a common factor, and it's actually something that we can factor out. We can factor out sin of x, and this sort of gives us, it gives us a hint on how we can go to the right hand side. Because we can factor out sin of x in the numerator, we should find a way to try and factor out cos of x in the denominator. If we can factor out cos of x in the denominator, we can actually reach tan of x on the right hand side, because we know sin of x over cos of x is tan of x. That's an identity. So the objective would be to try and write the denominator in terms of cos of x, because it's something that we want to factor out in the denominator, knowing that we can factor out sin of x in the numerator. So we can write the left hand side as follows. The left hand side is equals to sin of x minus sin of x cos of x all over. Let's see if we can write the denominator in terms of cos of x. I want us to pay attention to this expression, minus 1 plus sine squared of x. Let's see if we can use the identity sine squared of x plus cos squared of x is equals to 1 to write this here in terms of cos squared of x. So cos squared of x should be equals to 1 minus sine squared of x. If we multiply throughout with negative 1, we should get minus cos squared of x is equals to minus 1 plus sine squared of x. And that is what we have here. That is what we have here. So I'm going to rewrite the denominator in terms of cos of x. So this is cos x minus cos squared of x. So now we can factor out sin of x in the numerator and cos of x in the denominator. So in the numerator we have sin of x, what we left with is 1 minus cos of x, and in the denominator we have cos of x that we can factor out, and we're left with 1 minus cos of x. So these cancel out, and we know that sine of x over cos of x is equals to tan of x, and this is equals to our right hand side.